This is Tech Math 2.
Sorry.
And we're in section 1-8 and 1-9 today. And the rules for the class is that you will keep your cell phones on, so don't be turning it off. There's nothing to be sorry about.
I put it on vibrate. I'm sorry.
Yeah, perfectly okay, as long as we laugh about it. Okay, so we're going to multiply algebraic expressions. All right, so 2 times 2. And are we going to get 4 this time, or are we going to get 11? 4, okay, 4 this time. Okay, a squared times b squared times c squared times d squared.
Whoa.
A squared, b squared, c squared, d squared. Yeah, big deal, right?
Yeah, I got it.
A plus b, c plus d. AC plus AD plus BC plus BD. Okay, good enough?
Oh, I get it. Okay.
Yeah, so I'm going on A times that guy, A times that guy, B times that guy, B times that guy, and I wrote them all down, right? Now, it's not in this chapter, but if it were A plus B squared, then I'd have A squared. Well, I'll write it out. I'd have A plus B times A plus B. Then I'd have A squared plus AB plus BA plus B squared. And I'd write that as A squared plus 2AB plus B squared. And I'd skip all those steps. I just go from there directly to here, because in the front of my book it tells me that that's the case. So in the front of the book I have a x plus y squared, quantity squared is equal to x squared plus 2xy plus y squared. And I would remember that, and I'd skip all those other steps and just write down the answer. Yeah, we could use words like that to describe the situation. Yeah. But in general, we try not to use multisyllable words during tech math. So.
Multisyllable.
Yeah. Well, FOIL is only one word, one syllable, right? It's perfectly allowable. Number 3, 3a squared 4a cubed. Throw some parentheses in. Number 3. 4 times 3 is 12. And then 2 and 3 is 5, a to the 5th. So I add exponents of a common base, I multiply the numbers together, and I end up with something that looks like that. And my calculator can't do that unless I have a graphing calculator. Then it could, but then I'd have to have the instruction book with me to tell me how. So that is extremely counterproductive. Number 16, b to the 7th raised to the 6th. Okay, so that would be b to the 7th times b to the 7th times b to the... Why am I doing this? This is a waste of time. b to the 7th, b to the 7th, b to the 7th. So I got 6 of them. And I wouldn't do that. I just multiply 7 times 6. I'm just wasting time to try to figure out what 7 times 6 is before I put it down right. 42? Yeah, b to the 42nd. 7 plus 7 is 7, 7, yeah, exactly, 42. I knew that. So that the middle part we wouldn't do. We'd just go b to the 42nd. Or we might add a step b to the 7 times 6, followed by b to the 42nd. We could do that. But in general, our minds would rather not do something like that. 43. Okay, so I've got minus 4x, 3y squared, the whole thing squared. All right, so I'm going to have a minus 4 squared and I have an x squared on top. I'm going to have a 3 squared and a y squared squared on the bottom. And I probably skip that step too. 16x squared over 9y to the 4th. And then I'd ask myself, do I have any common factors between 16 and 9? And I'd say, no, I don't. 2 times 2 times 2 and 3 times 3, so no. Nothing common, and I am done. And my 8th grade algebra teacher is happy with me because I have positive exponents. I didn't leave there's no reason that this one would leave something in negative exponents, but I didn't mess up anything in negative exponents. So that is good. And one more time, we'll try number 46. Minus 2. I know, we'll get to that one too. 3 cubed. So minus 3 cubed would be a minus 8. We have a 27x to the 9th on the bottom. All right. So the class wants me to do 56 next so they can have a longer break. Okay, that's fine. 56. The cube root of 3, 4, 3. Now, does 3 go into 3, 4, 3? No, it doesn't. How do we know that? How do we know? I've got a number. 1, 2, 3, 4, 5, 6, 7. How do we know whether or not this guy is divisible by 3? All right, well, let's ask another question. 1, 2, 3, 4, 5, 6. Is that guy divisible by 2?
Yeah.
Yes, we know that because that guy there is divisible by 2. 1, 2, 3, 4, 5. Is that divisible by 5? Yes, because it ends in a 5. 1, 2, 3, 4, 0. Is that divisible by 5? Yes, because it ends in a 0. Okay, so the way we know that 1, 2, 3, 4, 5, 6, 7 is or is not divisible by 3 is we add up the digits. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. And why did I pick such a complicated one? I don't know. So that I have 8, and then I have a second 8, and then I have a third 8. So 3 times 8 is 24 plus 4 is 28. Is 28 divisible by 3? No. So because when I add up the digits, if they're not divisible by 3, then that number is not divisible by 3. So I've got 3, 6, 10. So I have the cube root. I have something that's a 10 when I add them together. That's not divisible by 3. It's not divisible by 2. It's not divisible by 5. All right. So the issue is, what are we going to do with that? Why don't we? The result's going to be an integer. All right. All right. So we'll move on down. We know all the knots. So cube root of 3, 4, 3. And we're going to go and see if 7 goes into 3, 4, 3. 4 times 28, 63, 9. Oh, very cool. So this is the cube root of 7 cubed. I didn't recognize 3, 4, 3 as 7 cubed, but after I divide it by 7, I do. Because 49 is 7 times 7, right? So this is the cube root. This is 7 cubed raised to the 1/3 power, because that's what cube root means, and this becomes a 7. And we got there because it's not divisible by 2, it's not divisible by 3, it's not divisible by 5. The next prime number is 7, so we'll try it. Okay, so that was pretty cool. 56. We just did 56. 60. There it is. The cube root of 1,000. All right, so this is the cube root of 10 cubed, which is 10 cubed. All right, so we're back to here, 1/3, and 10, 3 times 1/3, 10 to the first. So the right answer is 10, and we probably got that before we got down to here, right? And our calculator will do it for us because there's a nth root key in my calculator. So I can go second function, yeah, I'll clear up my second function, the nth root, second function, nth root. Okay, so we want to go, I think we want to go 3 second function, nth root of 1,000, maybe. Yes, very good. So if we entered in our calculator, second function, the blue guy that's box, root, 1,000, enter, we get a 10. And if we go second function, we got to put a 3. 3, second function, nth root, 343, I bet you enter. I bet you that guy gives us a 7, because that's what he better do. Okay, so 3, second function, nth root, 343. Boom, 7. So that would be good. Alright, so we need to get rid of something. So we'll get rid of that. Alright. So I guess we should do 84. What do you think? Well, we'll do 72 first. That looks like more fun. So I want the square root of 492. Alright, but this guy is divisible by 2. So if I have 492 and I go 2 times 2, 4, 6. And I go 2 times, because he's still divisible by 2, 1, 2, 3. And I see that 1, 2, 3 is divisible by 3, because 1 plus 2 plus 3 is 6. So it's 3 times 4, 1. 4, 1. Alright, so I'm going to have 2, the square root of 1, 2, 3. What do the instructions want me to do with the problem? Oh, round to 3 significant digits. Alright, what a waste of time. Square root of 492. Boom. Round to 3 significant digits. Alright, so square root of 492 is 22.2. Okay, problems with that? So I was going for an integer answer. There is no integer answer because it's an irrational answer, so that means I have to use my calculator. Do we have manual ways of finding a square root? Okay, so if I have 5 divided into 1, 2, 3, I can go 2, 10, 23 left over, 4, 20. 3, remainder 3, right? I can do that. So do we have a manual way to do square root of 1, 2, 3? Okay, we'll ask the question differently. Did your grandparents have a manual way to do square root of 1, 2, 3? Uh-huh. So so that's the issue. So I've got an 1897 arithmetic book that my grandfather used when he was in high school. And in fact, there is a manual way to do that. I don't know what it is. My manual way of doing it when I was in high school was use my slide rule. So my slide rule would take square roots very easily. So that wasn't, because it had a square root slide, and you just split it over to where it was and get it to you. Okay. Back to number 84 before we go to the next section to see whether or not we can actually do this one. Now, this looks like my X sub C formula, my reactive capacitance. 1 over 2 pi FC. But the frequency is way too low. Look at that. Oh, it's a square rooted thing. No, it's not that at all, is it? So that's not that. What is this formula of? So 1 over 2 pi, the square root of two things. Anybody remember what that is of? Okay. Because these numbers are the way they are, well, that's perfectly okay. That's the resonant frequency of an RC circuit. So if I had a circuit that had a capacitor and an inductor in it, this is the resonance frequency of that circuit. So this circuit will show a response like that, and right there is FR. Right. You do remember that. Oh, you can't remember that because that's part of it. Maybe anybody remember that at all? No, okay, well that's fine. We'll get to it later then. But anyway, we want to find this answer. So I'm going to go 1 divided by square root. And because I'm in classic and not math print, the parentheses automatically shows up. So there's an automatic parentheses that shows up when I do that. And I'm going to go 2 times pi times 1.23 double E key minus key, not the subtract key, but the minus key, 5 times 4.45 double E key, the minus key, not the subtract key, 12, close parentheses, and that should do it for me. Okay, how come my calculator went off anyway? All right, so 1 divided by parenthesis. Okay, square root of. And my square root of came up with a parentheses in it again because I'm in classic print. Yes, what's the question?
Well, we're still doing 1.7?
Yeah, we're doing the very last problem in 1.7. Yeah. Number 84, the very last one. Do you have an 84? Or did they skip you out of problems?
We did 84 last class.
No, this is 84, this class.
No, we did 1.7 last class. We did 20, 46, 70, and 84.
We did 84?
Yeah, last class.
We did? Wow. Where's my syllabus? Did I put the wrong problems on the board?
No, you just did them for
Oh.
one section.
We're supposed to be doing 1.8, 1.9. Okay, so the problem is we're doing 1.8, 1.9, and we have been working problems at 1.7. Oh yeah, way to go, guys. But luckily, David has caught up with us and has caught us doing the wrong problems. Okay, so we're back to doing 1.8. All right, we're going to do 1.8 problems. Okay, now I'm on the right page, number 34. Number 3. All right, well, 4, a squared b. These are almost the same, like 6a cubed b squared minus 24, a to the 5th, b to the 3rd. All right, so that was okay. Number 16. Maybe I'm just having mini strokes up here, I don't know. 4, a squared b minus 2 a squared b plus 6ab cubed. All right, so I got a minus 8, I got an a to the 4th b squared, I got a 24 a cubed b to the 4th. So I'm going to have two terms when I get done, so there's nothing I can do about that. 43. Oh, bummer. X plus y minus 7. X plus minus x minus y plus 4. All right, so I'm going to multiply the x by everything, and then the y by everything, and then the minus 7 by everything. That's my plan. And we're going to line things up. So I'm going to have x squared minus xy plus 4y. I'm going to have xy minus y squared plus 4y. I'm going to have 7x minus 7x minus 7y plus 28. And then I'm going to add them all together. And I'm going to have an x squared. That term goes away, so it's a 0. I'm going to have a y squared. I'm going to have a minus 7x minus plus 8y. No, there's a guy there too. So I have a 4y. I can't have a 4y.
You got it lined up.
This is a 4x. Okay, so that's a 4x. Boom, boom, boom. That guy. There's that guy's right. That guy's right. That guy's right. All right. This is minus 7x. Boy, did I ever mess this up bad? Minus 7x plus 7y plus 28. There, is that better? All right. So back to what we're doing. Minus 7 plus 4 is 3. So I have a minus 3x. I got a plus 11y. And I got a plus 28. And we normally write it in that order. We'd have the square terms first, and then the ones raised to the first power second, and the guy over there second. Now, this will boggle your mind slightly. Your mind ready to be boggled? If you were given this, could you factor it and come up with that? Could you do that? And the answer is no, you couldn't. You couldn't? Only if asked, right? It would be a stretch. Okay, so we normally don't do that. We normally don't go from the bottom guy up the other way. What was that? That's 43? Yes, it was. Number 56. This is, oh, what a bummer. Yeah. 2x plus 5 squared x squared plus 3x minus 1. All right, so I've got 2, I got 4. 4x squared plus 20x plus 25 times x squared plus 3x minus 1. And now we're going to do it again, and we're going to see if we can line up better this time. 4x to the 4th plus 12x cubed minus 4x squared plus 20x cubed plus 60 x squared minus 20x plus 25x squared plus 75x minus 25. All right, 4x to the 4th, 32x cubed, 81x squared, 55x, 25. And you say, well, maybe that's right. I don't know. But besides from having a calculator that won't do that problem, I do have a Maple program, which are all of $128 a piece. If you decide that you need one, which you probably don't need one yet. But if you were going to go on to get a 4-year degree in engineering, then you'd want one. So we're just gonna put it in Maple and see what Maple thinks. So this is 56. So I got that's not a parentheses. Parentheses. Where is the? There it is. Boom. Oh, that's right. 2 times x plus 5. Close parentheses raised to the 2 times parentheses x squared plus 3x. That wasn't an x, I know it. 3x minus 1. And we put in thank you very much, Maple. That was just so instructive. Was that instructive? Totally, completely. Simple expand. That's what I want. Expand the guy up there. There we go. Is that better? Is that what I got? Yes, I remember it. We'll go and do one of these things. So there's always another way to do more difficult math, is what I'm telling you. When the Maple thing came up, it said it's the power of 1,000 mathematicians. Well, yeah, only if you enter the right numbers, though. So we'll go and cut that and paste it up here. All right, well, that's good. Next problem, 60. 60. All right. So I've got 2 minus 4x cubed. And on the side, I write Pascal's triangle. Anybody remember Pascal's triangle? There we go. One person. Pascal's triangle. So I wrote it down. I start with a 1, and then I put a 1 down, and then 1 plus 1 gives me the 2, and 1 plus 2 gives me the 3. And those are the coefficients of this expansion. So I'm going to have 2 cubed plus 2 squared times minus 4x times 3 plus 3 times 2 times minus 4x squared plus minus 4x cubed. And there's an implied 1 sitting there. There's an implied 1 sitting here. All right, I'm going to do this more than one way, by the way, but I'll do it this way first. Okay, so I've got 8 plus minus 4 times 4 times 3. Is that 48? Minus 48x plus 16 times 6. Yeah, I can't do that in my head. 16 times 6. 96. 96x squared minus, was that 64? 64x cubed. Okay, now that was cheating. Was that cheating? Yes, that was cheating, because we don't know Pascal's triangle yet until chapter 10 or so. So that means I have to do it differently. I've got to go 2 minus 4x, 2 minus 4x, 2 minus 4x. Right? And I go 2 times 2 is 4. 2 times 4 is minus 8x. Minus another 8x plus 16x squared times 2 minus 4x. Alright, so I've got 4 minus 16x minus plus 16x squared times 2 minus 4x. It was much easier the way I did it, though. Wasn't it easier? Alright, so I've got 8. I've got minus 16x. I've got minus 32x. I've got plus 64x squared. And then I've got plus another 32x squared minus 16x 64x to the fourth. Alright, so I've got 8 minus 48x plus 96x squared minus 64, that's a cube, x to the fourth, which is exactly what I got the other way, but we don't know those other ways yet until we get further out in the book.
Where the cube come?
What? Where's the square?
No,
Where's the square guy? Where's the cube guy? How come I'm missing terms? Oh, bummer. Bigger eraser. I'll do it again. 4 times 2 is 8, minus 16x. Okay. I got another minus 16x, and then I've got a, right, there's no fourth term. You're right. Where are we? Plus 64x squared. Then we have a plus 32x squared minus 64x cubed. There, that better? 8 minus 32x plus 96x squared minus 64x cubed. All right, better? All right.
No,
That's not the same?
One of the earlier answers, or one of the earlier questions we did.
Yeah.
You put the cube, like you put the cube first, the square second, the x
Yeah.
third,
Mm-hmm.
and the number fourth. Is
Yeah.
that the way we're supposed to put it, or does it matter?
Now, you have, this is a apples and oranges question. Apples and oranges. All right, so there's nothing wrong with that answer. This is a tech math class. There's nothing wrong with that answer. If this were a math class, there would be something wrong with this answer. What is it? What is a math class? If this was something other than a tech math class, what would your ninth grade, right, you're leading with a negative number, and your ninth grade algebra teacher would tell you, don't lead with a negative number, and hit you with a ruler, right? Well, if you're a parochial school, probably. You probably don't do that in other schools. But, you know, Sister Louise would lead with a negative number, right? Yeah. So, but because this is a tech math class, both of those answers are totally acceptable, and we just move on. Okay. So that's, but yeah, if this were a real math class, then calculus 1, for example, then we wouldn't want to lead with a negative number. That would not be acceptable. Okay, so now we're going to divide. So number 2, we're going to go and divide, and we're going to have minus 18 x squared y cubed divided by 3xy. And we're going to see that 3 goes into 18 6 times, x goes into x squared, and y goes into y cubed, and we end up with minus 6xy squared. Now, your calculator is not going to do this problem even though you can enter it, because it's a numeric machine and it wants numbers to be in x and y to give you a number. And so that's why but your graphing calculators would do this problem if you wanted to pay a couple $100 for one. Not a good idea. 20. This is the calculator that I took to the comprehensive exam for my master's degree in math. $20. And I still passed. I also took this book, and 3 of the 6 questions came out of this book. Answers came out of this book. Yeah, totally amazing. And I only had to do 4. Number 20. What was I doing? What was I thinking? Okay, so 27x cubed, 18x to the 5th, 36x to the 4th, 12x divided by 9x cubed. All right, well, I look at 27, 18, 36.
27 to the 8.
What? What'd I do?
You had 27x to the 3rd instead of 8.
Oh, this is an 8. All right, so you want me to do the problem in the book? How boring. Okay, well, I look at that and I say, well, I have a 3 in each of those guys, don't I? So I can divide this guy by 3 and get a 3, and divide these guys by 3 and do that. So that simplified it a little bit. Then I'm going to go 3x cubed, and I'm going to divide it into 9x to the 8th, 6x to the 5th, 12x to the 4th, minus 4x. All right, so I'm just going to do that. This is going to go there 3x to the 5th times 9x to the 8th, minus 6x to the 5th. That's going to go in there minus 2x squared times minus 6x to the 5th. I get 0 again. 12x to the 4th. Going to go in there 4x times 12x to the 4th. I get a 0 minus 4x. I'm going to get a remainder of minus 4x. Okay, besides from this stupid 3 being here from, oh, that was good, wasn't it? No, that was just wonderful. Right, so put that line back, and this was 2x squared plus, okay, and then we'll put this 9 back here, and then we'll cross it out there and put a 3 up there. Okay, good enough? So we're dividing a polynomial the same way that we would divide numbers, right? That's all we're doing. Well, if I go 1, 2, 3 divided into 1, 2, 3, 4. Goes in there 1 time, 1, 2, 3, remainder 4. No, 0, remainder 4. Okay. 4 minutes to do problem number 44. There is harder ways to do this, but they'll be later. I've got 16a to the 4th plus 1 divided by 2a minus 1. Okay, well, let's see, 16a to the 4th plus 1, and I'm going to divide 2a minus 1. So it's I'm gonna rewrite this a little bit. I'm gonna go and put my plus 1 over there. Okay, so 2a goes into 16a to the 4th, 8a cubed times. So I got 16a to the 4th minus 8a cubed. I subtract, I get a 0. I subtract, I get 8a cubed. Okay, and 2a goes into 8a cubed, 4a squared times. And I multiply out, I got 8a cubed minus 4a squared. I subtract, and I get 4a squared. Goes into there 2a times 4a squared minus 2a. I subtract, and I get 2a. Alright, I'm going to go in there plus 1 time. I get 2a minus 1. I subtract, and I get a 2. So 1 minus a minus 1 gives me a 2. So I got a remainder 2. Okay, good enough? Okay, with that, we have made it through section 1-8 and 1-9, doing some 1-17 on the way.